So hello guys, my name is Pavel from blenderfreak.com, and today we will have a look on how to create a smoothing fly-through camera here in Unity 3D. As you can see, it's basically a script attached to the main camera, and you will be able to adjust the speed, sensitivity of the mouse look, if the y-axis is inverted or not, and enable or disable the smoothing and acceleration. So when I press play, you can see I do have some testing scene here. When I press a key, the camera is slightly moving. You can turn it on or off, and you will have the basic simple fly-through camera as usual. So I hope you will like it, and the source code is available as usual on the blog post on blenderfreak.com. So let's go start do the work. So the fly-through camera will be created in 3 steps. The first one will be the WASD movement of the camera, and after that we will add a mouse look to it, and in the finish we will smooth the movement of the camera. So we know that in a 3D space in Unity, every object has 3 axes, X, Y and Z, and we want to move the camera along these axes when pressing WASD keys. So let's create a direction vector, and when we press W, that means forward, then we will add 1 value to our local vector, which will be the direction. So the length of the vector will be 1, because it will be 0, 0, 1. But imagine when we press 2 keys together, then X and Z will be 1 and 1, so the length of the vector won't be 1 anymore, it will be the square root from 2. We need to remember to normalize our vector, and when this part will be finished, then we will move to the mouse look, which will be quite simple. Imagine that we have a 2D screen and suddenly we move the mouse cursor, so we need to somehow remember our last position, so we can get the vector of the difference of the mouse move. So this will be a 2D vector X and Y, and here is the question how to translate this 2D vector to the 3D space. So actually we won't move the camera anymore, but we want to rotate according the movement on the 2D screen. So when we actually let me switch to the tablet, and I will draw here in the picture. So when the X value will change of our mouse position, then we want to rotate the camera along the Y-axis, because we want to tilt it left and right. So the 2D X component will translate or transform to the rotation along the Y-axis, and when we tilt it up and down, then the Y value will change, and this one will rotate the camera along the X-axis. So it's quite interesting to notice that the 2D XY will translate to 3D YX. So the coordinates are flipped for this, and in 2D space it's translation, and in 3D space it is actually rotation. And we will use the simple Euler rotation here. So lastly, when we want a smooth movement, imagine the direction vector will be 0, because nothing is being pressed until we press a key. Then suddenly the direction vector will be 1, so the camera starts moving, and it will keep moving until we release the key. So let's draw it somewhere here, and then again suddenly the direction vector will become 0, so there will be no movement for the camera. And for the smooth movement we do want to have a quite different behavior. So the speed of the camera will be 0 until we press a key, and when we press the key the speed will grow up in a time, then it will keep at the maximum speed of the camera, and once we release the key the speed will fall down. So the actual formula for our camera movement will be the direction, which will be a vector, multiplied by the maximum speed of the camera, then multiplied by the actual speed, which will be a float value from 0 to 1, which will determine how fast is our camera currently moving. And because we will do it in update function, we multiply this with time.delta time, which is the difference between the frames. So let's get coding. Here we are in Unity. I started just a new project. I will quickly add a few things here to be able to recognize what's going on in the scene. And the first thing, I will add a plane. I will scale it up a little bit, maybe something like that. Okay, and I will add a few objects here, like for example this one. It doesn't matter which one. Will move the camera up a little bit. Ctrl C, Ctrl V, and finally adding a directional light somewhere here, and here's our camera. When we press play, nothing's going on. I will save the scene. Like this, and all we need to do is create a script, Flycam, and then I will attach it to the main camera like this, and you can see the flying camera is here. So I will open the monodevelop for it, and the things which will be used is this transform here. Because our script is attached here to the camera, we can access the transform property by simply putting transform, and that's all. So as I explained, we do need a few variables. So first I will create a public float speed, which will be example 50, which will be maximum speed of our camera. And let's go here to the update function, and we will say we will create a new variable called direction, or dir, and this will be new vector3. Okay, and this will create 0, 0, 0 vector. And then we'll just simply check out the keys. If input.getKey will equal to keycode.w, and we don't need this here, then our direction will be along the z. So we will say direction dot z plus equals 1 0.0 f, and the opposite for the S key, but this will be minus. Okay, let's check it out if it's working. Let's play. And it's not working because we didn't translate our camera. And the translation, yeah, we want to normalize our direction, and the translation will be transform, I believe. And here is a translate function, and we will say our direction multiplied by speed and by time, delta time function. Now when I press play, you can see by pressing W and S the camera is moving forward and backward. No mouse move, no left right, so let's add quickly the left right, and the first key will be E or A, and we will be moving along x-axis, and we will decrease it by 1, and the right one, D key will be +1. Okay, press play, and you can see we can move our camera, and even when we press W and D, it's moving diagonally, and the speed isn't changing because we do have our vector normalized. So this is the first part. This is the movement of the camera. And now mouse look. Okay, so the mouse look, as I explained, one thing we wanna keep is private variable. I will use vector3, and this will be last mouse position. So be new vector3, and this will be for the start, let's say not 0, because 0 will be up top left corner and we don't want this, so I will just put some values here like this. And when we are doing the mouse look, we will do some stuff, and then we want to store our last mouse position, and this will be equal to input dot mouse position, and mouse position is vector3. That's the reason why I'm using vector3, even if we won't use the Z at all, but never mind. So the stuff to do here is you want to calculate our vector here, which will be, let's say, yeah, it will be the new position, actual position, minus the last one. Yeah, so that's the difference there. And then what we want to do is calculate the new vector here, and it will be our camera. So transform dot Euler angles, or Euler, I don't know, and the X rotation plus our last mouse dot Y and the reason why it's flipped I explained. So the second parameter, the rotation not along the x but now the y-axis, will be again the transform your angles y plus and our difference vector, which is stored in last mouse, on the x, and no rotation along the z-axis. Yeah. So then we will just use transform, and we will set the new Euler angles to the last mouse. So let's test it out. And our camera is moving. And I'm moving left, it's looking left, right is looking right. When I go down, the camera looks up, and otherwise. So that means that our rotation along the x camera or x-axis is inverted. So usually you can see a flip or a Boolean value for the inverted camera, and we can say because our x was flipped, so the last mouse y was flipped, so we can say if not inverted, then last mouse y equals minus last mouse y. Save. And we added a new checkbox here, as you can see, and now when I'm looking up, it's going up, and down is going down, because it's not inverted. And when I check the inverted button, then you can see by moving up, the camera is going down. Yeah. And so the other touch will be a float, and this will be the sensitivity, and this will be, let's say, 0.25, and I would suggest to keep it from 0 to 1, because we can change our last mouse vector by the sensitivity, like this, and this will be just a value to control our sensitivity. So when I change it to 1, as you can see, the camera is quite too sensitive. When I put it again back to 0.25, which is 1/4, you can see the camera is not being so sensitive at all. So this is the mouse move, and because we are moving by the axis or by the direction in the local space, we are translating, we can fly the camera all around as we want. Okay, even diagonally, and it's keeping still the same speed. So the last part will be the smoothing. So for the smoothing, we will create a public bool variable, or checkbox for smoothing, and by default it will be enabled. Yeah. Okay, and how this will change. So here is the mouse look. We don't want to touch this, and we will create a new variable. As I explained earlier, this will be private and float, and it will be actual speed, and from beginning it will be 0, and we will keep it from 0 to 1, again the same way as the sensitivity. And what does it mean? That means that when nothing is being pressed, then we want the speed or the actual speed to fall down from 1 to 0. Once we start pushing a key for the movement, we wanna slowly increase the speed. So we can do it, we can check long if any of these key was pressed, or once you realize that if something is being pressed, the direction will change from 0 to some vector. We can just check simply if direction doesn't equal vector 3 dot 0, the 0 vector. So this way we know that some movement is going on, and otherwise the camera should stop. Okay, so we press the key, our actual speed is 0, so we want to increase our actual speed by some acceleration. And we will multiply it by time dot delta time. But we don't know what the acceleration is, so this will be public float again, acceleration, and this will be, I don't know, 0.05, something like this. And when nothing is being pressed, so we want our actual speed to decrease by the acceleration. But this is not sufficient, because it will keep decelerating all over and all over again below the 0, below everything, and we want to keep our actual speed from 0 to 1. So we can say just if our actual speed is less than 1, then do the acceleration thing. And the same thing for the 0, if our actual speed is more than 1, then our actual speed will decrease, or more than 0, excuse me. And we're not having any glitches here, like this is 0 and this value will be higher than the actual speed just above the 0 one. You can say otherwise, rather set the actual speed directly to 0, and the same thing here. Otherwise, in the case that something is bigger than 1, then select or set the actual speed to 1.0. Okay. And just to check it out, I will add a test function here on GUI and call GUI layout dot box, and this will be actual speed plus actual speed dot to string. Okay. An error. Literal type doesn't have F. Fixed. Okay. Display, and you can see our actual speed. And as I hold the key, you can see the actual speed is gaining or increasing, decreasing, but it's too slow. So I can do a quick adjustment here. Basically, if I start pressing the key, I do want to move it quickly up, rise it up quickly, and when the speed will be decreasing, it will be a bit more slower, so I will multiply it by 20. Press play, and it's 1. And it will be still moving, so let's try 0.1 here. Yeah, and this is more, I like it. The smoothing is much quicker. So I will change the default here to 0.1. And now to change the formula here, this will be multiplied by actual speed. Display, and you can see when I start pressing, it accelerates, but when I don't press the key anymore, suddenly the camera stops. And the reason why, it's pretty simple. When no key is pressed, the direction equals to 0. But if we do have some actual speed, when the direction is still 0, we wanna move in the last direction. It was there. So we can say, if there is some movement, set our last direction equal to direction, and when the movement stops, just keep the last direction. So private vector 3 last direction will be new vector 3 to keep something stored in. So now when I press play and I will start moving, you can see the camera is slightly increasing the speed and decreasing when the key is pressed down. And you can always change the acceleration here, and the smoothing checkbox is not working right now because we haven't implemented it yet. So yeah, the checkbox is off and it's still moving smoothly. So what will be the change if the smooth, this is a, if smooth is enabled, then we want transform by this formula. Otherwise it will transform different way. Translate, and this will be actually not the last direction, because last direction keeps the, even when nothing is pressed, then last direction is having or containing the last direction where the camera was moving. So we don't want to have last direction here. Instead of that, we will use the actual direction, which is right now, depending on the keys which are pressed. We will skip the actual speed because it will be always 1, and we will multiply it then by maximum speed and by time dot delta time. Okay. And now when I press play, you can see there is a smoothing. When I turn it off, you can see no smooth movement anymore. So here is basically everything you need to adjust your fly-through camera, the speed, sensitivity, if it's inverted by the y-axis, if there is a smooth movement or not, and the acceleration of the smoothness. So I hope you have learned something here and there. If you have any questions, please ask me. I will be glad to answer you, and as usual you can download the Unity package on my blog site on blenderfreak.com. and I guess this is everything for me for now, and good luck in your project, and see you next time.